Good morning, 7th grade. Today I want to continue our review of probability by talking about dependent probability, also known as probability without replacement. Now, this specifically is going to be about compound dependent probability. So multiple things are happening, and once one thing happens, it changes what can happen the next time. So, I have this very poor drawing of a bucket full of marbles. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marbles in here. And let me actually go up here. I want to get this menu. Okay, so let's say that you want to know the probability of getting the sequence. I'm just going to use the first letter of each color. Blue followed by a red. Now, because this is probability without replacement, once we take this blue marble out for our first pick, we're not going to put it back in. Let's start out by figuring out the probability of pulling out this blue marble to start. There are 12 marbles in the jar to start. How many of them are blue? 1, 2, 3, 4. So the probability of drawing that first blue marble is 4 out of 12. So let's actually make that happen. I'm going to grab, this blue marble. I'm going to pick it up, and I'm going to move it outside the bucket. Hey, I win if I get a blue and then a red, and I draw a blue. Great. But notice that now this blue marble is not in the bucket anymore. So that means that the probability, the fraction we're going to use down here, is going to change for this second draw. How is it going to change? Well, how many marbles are actually in the bucket now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Because this blue marble is on the outside, there's only 11 marbles left. How many of them are red? 6. Now that we have our two probabilities, because this is compound, we're going to multiply them together. Well, let's see if we can simplify first. What can 4 over 12 simplify to? That's going to simplify down to 1/3. Okay, now let's multiply. 1 times 6 across the top is 6. 3 times 11 across the bottom is 33. So the probability of getting blue and then red without replacement, because we leave the blue one over here, is 6 out of 33. Can you figure out what the odds would be? Try it out now. All right, let's do a new problem. Let's put the blue marble back in the bucket, and then let's get my marker here. I'm actually going to switch over to purple. Okay, let's do a new one. Let's say that we need to get the probability of red and then green and then blue. Okay? Now, when we're doing this without replacement. So, our first draw is normal. There are 12 marbles in the bucket. How many of them are red? I count 6. Next, okay, so hold on. Before we do that, we have to, because we're not putting things back in the bucket, let's say, I don't want to do that. I just want to grab this one. We take out that first red marble and we set it aside. Now the probability of things has changed. For our second draw, now there are only 11 marbles left in the bucket. How many of them are green? I count 2. Great. So let's grab one of those green marbles and put it outside the bucket. We pull the green marble out the second time and we set it aside. We don't put it back in. So how many does that leave for our third draw? Well, now there are only 10 marbles in the bucket. How many of them are blue? 4. All right. So notice that what happened on the first draw changed the numbers for the second draw, and the second draw changed the numbers for the third draw. This is dependent probability. What happens before changes what is happening now. Let's do our multiplication, since we now have our 3 individual probabilities. Okay, so can 6/12 be simplified? Yes. That can turn into 1/2. Multiply. 2/11, well, 11 is prime, so we can't simplify any farther there. So we have 2/11. And what about 4/10? Can that simplify? Yes, it can. It can become 2/5. And now we multiply. 1 times 2 times 2 is, of course, 4. And then 5 times 2 is 10. Times 11 is 110. We can do even more simplification here. Both 4 and 110 are even. 4 divided by 2 is 2. 110 divided by 2 is 55. So the probability of going red, green, blue without replacement is 2 out of 55. Let's jump over to the worksheet from your packet last week. Now, this is the exact same set of problems that we talked about yesterday. But what we're going to change today is we are going to assume that instead of putting the marbles back in, we're going to ignore these questions. Don't worry about them right now. Instead of putting the marbles back in for these problems, we are going to assume that once we take a marble out, it doesn't go back into the bucket. Now, I'm not going to go through all 4 of these like we did yesterday because that would be a repeat in some cases, but I do want you to keep in mind as we go through these 2 examples that once we pull out a marble, we're not putting it back in. Let's start with number 1. So we want the probability of the exact sequence white, blue, red. So let's first find the probability of a white. Well, in our first draw, all 60 marbles are still in the bucket. How many of them are white? 12 of them are white. So we're going to put that as our first fraction. Multiplication symbol. Now, here's the thing. Once we pull that first white marble out, we're not putting it back in. We're setting it off to the side. So now instead of there being 60 marbles in the bucket, there are 59 marbles in the bucket. How many of them are blue? 6 of them are blue. That's our numerator. Put our multiplication sign. We've now removed a white marble on the first draw and a blue marble on the second draw. We don't put them back in. So how many marbles are left for our third draw? We now only have 58 marbles left. And how many of those 58 are red? 10 of them are red. Notice if you compare this to yesterday, the top numbers are the same, but these bottom numbers are different. And that's going to change our calculation pretty drastically. Let's see if we can simplify before we do our multiplication. 12 over 60 can simplify down to 1/5. 6 over 59, 59 is prime, so we can't do anything with that. That stays the same. What about 10 over 58? Well, both 10 and 58 are even. We can divide them by 2. 10 divided by 2 is 5. 58 divided by 2 is 29. So this is a much funkier calculation than we had to do yesterday. Let's do across the top. 1 times 6 times 5 is going to be 30. And across the bottom, we have 5 times 59 times 29. Not exactly something you can necessarily do in your head. So grab a calculator. This is crazy. Your answer, your denominator here is going to be 8,555. Now, can this be simplified any further? Think back to 6th grade. There's a rule that we learned. If a number ends in 0 or a number ends in 5, any number that ends in 5 or 0 must be divisible by 5. So 30 divided by 5 is going to give us 6. And 8,555 divided by 5 is going to give us 1,711. So the probability of getting the exact sequence white, blue, red without replacement, without putting the marbles back in the bucket, is 6 out of 1,711. All right, let's jump to number 3 as our final example of the day. So this time we want to do odds, but our initial process is going to be the same. We're going to find each individual probability, multiply, simplify, and then we're going to take one more step after that and turn our final fraction into an odds ratio. So what are the odds of yellow and then white? And remember, this is without replacement. We're not putting it back in. So our first draw is going to be normal. They're going to be all 60 marbles in the bucket. How many of them are yellow? 2 of them are yellow. Put our multiplication symbol. Now, we don't put that yellow marble back into the bucket. So there are no longer 60 marbles. Now, there are only 59. And how many of them are white? 12 of them are white. So we've got our 2 individual probabilities, and now we have to combine them by multiplying. But wait a minute, let's simplify first. 2 60ths can become 1 30th. And then 12 59ths can't change because 59 is prime. So there's our simplified multiplication problem. 1 times 12 across the top is going to be 12. 30 times 59 across the bottom. Oh boy, what is that going to be? 30 times 59 is 1,770. But wait, both 12 and 1770 are even. So let's divide that by 2. We have 6 over 885. Now, I'll be honest. If you stopped here and turned this into odds, I'd be okay with that because this is a kind of a funky set of numbers, and maybe it's not obvious that this can actually be simplified even farther. 6 can be divided by 3, and 885 can also be divided by 3. So this would become 2, and then 885 divided by 3 is 295. Let's turn both of these into odds just for fun. So 6 over 885. Remember, it's losers on the left, winners on the right. How many ways are there to win? There are 6 ways to win. If there are 885 total possibilities and 6 of them are winners, all the rest must be losers. That means 885 minus 6 is 879 to 6. What about 2 over 295? Well, there's 2 ways to win. That goes on the right. Losers on the left. 295 minus 2 is 293. So the odds of drawing a yellow followed by a white without replacement is 293 to 2. All right, I hope that helps. There is a short 6-question assignment today, including a new scenario where, I'm going to pull it up for you. There are note cards in a bucket. Each note card has one name from the 7th grade on it. And once you pull out a note card, you do not put it back into the bucket. And I want you to figure out the probability and odds of pulling out certain names. As always, do your best, stay safe, wash your hands, stay home as much as possible, and I'll see you soon. Goodbye.